So, we're doing position vectors today. So what I'll do for these videos is we'll do like an example and then I'll stop it so that afterwards, if you ever would, even if you were in class, like to go back to an example, then I'll try to save the videos as in, like this topic is position vectors, and then example 1, position vectors, example 2, and so on, so that if you just wanted to see one, you don't have to watch the whole video and find it. Hopefully that works out pretty good. And oh yeah, last time we had the mic out in the audience so that Liam was making commentary throughout. Should we hang a mic from the top so people's comments come up? Yes. We got the extra one here. Should use it in my other classes when people talk too much. I could put the mic right beside them. Oh, is it out of batteries? Oh, the other one's out of batteries. Oh well, here we go. So when you watch this in real time online later, you'll be able to find out how much time you had to write the word position and determine if that was enough time or not. You're good? Okay. This is a microphone around my neck. Yes. No, just recently once I get this hooked up. So I tried to convince my grade 9s that I was Iron Man and I needed this in order to live, but they didn't believe me. Some said they hadn't seen that movie yet. No. So what we do in vectors is we start to see how we can write another vector in terms of other vectors. And what this will do is make some math easier to do and to solve things. So right now we're just going to practice. I have M as a position vector going from O. O would be the origin, out to a point M. And little n as a position vector going out to a point N. Now, if you had a line going from M to N, what you could do is you could write it in terms of these other two vectors, M and N. So in other words, if I wanted to start from M and I wanted to get to N, one way I could do that is go back to the origin, and then once I got back to the origin, I could go out to N. That's not the most efficient way when walking, right? There's often you want to take the most direct path, but it would still get you to the same place. So what we could say is we could say if I wanted to go from M to N, I could first go from M to the origin, M to O, and then go from O to N. Moon. Something like that, some kind of eclipse. So stay up. Yeah, it's going to be cloudy. And going from M to O is the opposite direction of going from O to M. So now we've written that you could go from M to M if you went minus M first and then added N. Every time we have a vector, when they're written, they're bolded in textbooks, but it's hard to bold while writing, so we underline them. So part B, Kyle, ready?
Yeah, I'm good.
You're good? All right. Now think about going from N to M. Try this one on your own. See if you can write N to M. So using the same strategy we used last time, you could go n to O first and then go from O to M, which would give you negative n plus m. Question? Yeah? Got it? Why would NO? Because if I started at N and went to O, that's the same length, same magnitude, same direction, opposite direction now, right? So anytime you're going the opposite direction, you're going negative. Another way you could think of it is we figured out Mn last question, right? Mn was negative m plus n, right? You could just multiply that by a negative, and you would get the same thing. Because Nm is the same magnitude but opposite direction of Mn. And now what you can do is you can start doing other points. We can put a midpoint point P in here, and we can find out what its position vector is from O to P using only M and N. If you wanted to start at O and get to P, does it make sense that you could first go to M and then go halfway from M to N? So now we put our things in here. We know that OM is M, and we figured out what Mn was before, which was minus M plus N. And combining your like terms, you've got half of M plus half of N. Visually, what this final statement means on our graph is I'm starting at my origin, and I'm going halfway along M and stopping when I get halfway. Then my n vector goes in this direction, but I only go half of that n vector. So when we're talking about vectors, they're not set in place. You can go in that direction at any time and that length at any time wherever you are. And it's just a matter of finding out what that final thing looks like as a result.